Alright guys, welcome back. Hope you enjoyed your wonderful snow day. You're actually watching this the day after I'm recording. I'm recording this on Monday, the 3rd of February. Unfortunately, the groundhog decided to see his shadow, so we have 6 more weeks of winter, which probably means we're going to have more snow days than just today's. So what I'm going to try to do is I'm going to try to have these videos. If they are working and doing well, then every time we have a snow day, instead of those blizzard bags that I made up for all those classes, this will be your blizzard bag, is to watch this video. I will email you guys with the link, um, and we'll just take it from there. Kind of playing around with this technology that I have. So if I seem a little fumbling, forgive me. I'm getting used to this. You guys are my guinea pigs. So today we're actually starting in section 7.6. You guys will have just finished 7.5 in class, and you'll have a little bit of homework from that, but because you're both watching this video and working on the homework, I'm gonna make sure that the homework isn't that bad for you. But what I want to talk about today is graphs of the sine and cosine function. That's not exactly what I wanted to do, but let's go to whiteboard. Aha, here we go. Or let's do a green chalkboard. All right, so today what we're doing is we are covering um, sine and cosine graphing. And how we graph with sine and cosine, I don't know if you covered in pre-calculus last year, but we're going to spend some time getting in depth with it here. So what I want to do is I want to first talk about a sine graph. And with a sine graph, basically, what it is you have your coordinate plane, and our sine graph starts at the origin here, and it goes up, then back down, and then it comes back up, and essentially it repeats itself over and over and over again, so that, and let me see if I can get back to the computer. There we go. So that when we're done, it looks like that. See, this is a sine x, and see it starts at our origin, then it comes up, then back down, and this really isn't a good representation. Let me see if I can set when. All right. So my window I want to make from -1 to +1. Nope, not there for the x. I want to keep the. I want to do negative. I want to. All right. So I accidentally turned my computer off. So you didn't notice it because it let me just start right back on the. Video. But anyway, we're going to go from -10 to +10 there. But for our y, we're going to make it go from negative, let's do -5, no, -1 to a +1. And we're going to set our, let's set it in degrees. So we're actually going to go -720, and we're going to go to +720. And the reason I'm doing that is because I'll explain it here in just a second. And actually, I can label this. Oh, perfect. I'm just playing around. Sorry, guys. We're just going to do this. There we go. And we're going to keep it in degrees. All right, perfect. So let me get out of this. So if you notice, this graph starts at 0, goes all the way up to 1, and down, and it crosses at pi, and down, then back up, and it starts over here at 2 pi. Now, if you remember back from our unit circle also started over at 2 pi. So sine graphs and cosine graphs have a really tight relationship with our unit circle. When we graph this, as you can see, we have sine x does this, but what would happen if we made it sine of 2x? What happened? Well, it got tighter, as you can see with the green. Instead of it starting over at 2 pi here, the green starts over at pi. And so on and so forth. If we did sine of 4 pi, or 4x. If you can see the purple, I'm going to actually X out of the red so it's not as busy. And I'm going to change the window from -5 to +5 just to kind of spread it out a little bit. But if you look, the purple is down and comes back up, and it starts over right here at pi over 2. So every time you double this, it shrinks the graph, it squeezes it in half. Now, what would happen if I had just sine x? So I'm going to get this back to the original. And what if I had a 2x out here? Well, as you can see, it does the exact same thing. Okay, but what if I did that? Now it goes off the graph, so I'm going to have to go back to my window settings, and let's put it at -3 and +3. And as you can see, the green one is our original one, sine of x. So, and let me change that window actually to be -10 to +10. Okay, and the green restarts at 2 pi, and the highest point's 1 and lowest point's -1. But if we put a 2 in front of this sign here, now what happens with the purple is it goes up to +2 and down to -2. This is called the amplitude. This number right here is the amplitude. And basically how the amplitude works is it's the highest point and the lowest point of our sine and cosine graph. So if this was a 5, then it would all the way up to, it would go from -5 to +5. You see that? The green hasn't changed, just with the stretching of the graph, it looks like it's getting a little bit less steep, but that's just because we're now zooming out a little bit, actually shrinking or stretching zooming out on the y values. So this is how sine graphs are done. Now, what is it? We're going back. What about a cosine graph? Well, a cosine graph, once again, you have your coordinate plane. And actually, let's go and let's look at the, there we go. Let's change this from sine to cosine. And if you notice, the difference is now it doesn't start at the origin, it starts up at 1. And what if we change the amplitude to be, let's make it 3 cosine x. Now it starts, instead of starting at 1, it starts at 3. Okay? And once again, it starts over at 2 pi, which is the distance around the unit circle. But the amplitude is now 3 and -3 for the orange, 1 and -1 for the green. That's where the high and the low is, and the amplitude is the absolute value of whatever's in front of our cosine or sine. So in this case, it would be 1 for the amplitude. In this one, it'd be 3. What would happen if we made it -3 cosine x? Let's see what happens. -3 means we start our cosine graph down 3. Okay, once again, the amplitude is 3 because we use the absolute value. Okay, let's go back to sine real quick. I forgot one thing I want you to see. Now with sine x, it starts at our origin and goes up. Then at pi over 2, it comes back down, and then at pi, it crosses. Now if we had negative sine x, that basically means we have -1 sine x. Our amplitude's the same, 1 and -1 is the high and low. But instead of going up, now this red, it's going down, then back up. So this point right here is pi over 2, -1. This point is pi 0, 3 pi over 2, 1, 2 pi 0. This point right here, pi over 2, +1, pi 0, 3 pi over 2, -1. And once again, that's 0, 0, and it even goes backwards. Kind of looks like a DNA double helix if you would include some lines, but that's not for this class. So, I hope I'm not boring you guys, being really dry. I want you to tell me how you like this video, what I should improve on, what I need to, what's good, what's bad, that sort of thing. Like I said, you guys are my guinea pigs. Now, we talked about amplitude. Now, what would happen, like I said, what if we did this? It's 2x. Now, see, it got a lot tighter. So what happens is this is called a period. And a period basically is when the sine cosine function restarts. It's a period. It's a period of time, kind of like the Renaissance period, or like any kind of period of time. Class period. It has a set time, and then you move on. When we are dealing with sine and cosine, it's the same thing. It's when it starts over. So for sine, our period, change this. We're going to look at the red one. For sine, our period is 2 pi in radians. In degrees, it'd be 360. But in radians, it's 2 pi for sine x. Now, sine 2x, the period is just pi. Now, there's an actual formula that goes with this. And the formula for the period is 2 pi over k, where our equation is cosine or sine of kx. This number in front of our x, or in front of our theta, goes here. Okay, so if we are dealing with maybe 3 sine of x, what number's in front of x? So 1, so 2 pi over 1. Our period would be 2 pi. However, if we did sine of 4x or 4 theta, we would take this 4, I want green, I want this color, and do 2 pi over 4, which is the same as pi over 2. So our period is pi over 2. So when we have our graph for sine, it's going to restart at pi over 2. Okay, now in between here is where it's going to cross. So this is going to be pi over 4. And then here's where it peaks, here's where it valleys. This is pi over 8, because we're cutting it in half. And this is 3 pi over 8, because that's halfway through there. Okay, and once again, if we would graph this, all we need to do, it's a sine function. So we start here, okay? The amplitude in front of here, it's 1, so we're going to go up to positive 1 and negative 1. Okay, so it's going to come, so we're going to touch there, and we're going to cross through there, and we're going to touch there, and we're going to come back through there. So our graph, this stylus isn't the best one. I'm waiting for my new one, but it hasn't arrived yet. But this is our graph. I hope that makes sense. I really can't get your feedback. Basically, Thursday, you guys are watching the, or I'm sorry, Wednesday, you're watching this Tuesday night. Wednesday, I will answer any questions, alleviate any misconceptions, that sort of thing. So, that is, I think, our lesson in a nutshell. Let me double check. And one last thing I want to talk about is finding the amplitude and period. Okay, so finding amplitude and period. And basically, what we're going to have to do here is we're going to look at a graph, and we are going to figure out what our amplitude and our period is. So what we're doing is I'm going to type in an equation, and we're going to ignore what the equation says over here. We're just going to come over here, look at the graph, and figure out what the amplitude and the period is. So let's actually do this one. More pi over 2. Oh, this is cool. X. All right. So, and I can even zoom in and out. That's kind of cool. So what we want to do is we want to figure out our period and our amplitude. And I'm actually going to use this function. I'm going to use this drawing mode function. What I'm going to do is first I'm going to look at where the high and the low is. Okay? The high and low is essentially our amplitude. Okay, now we're going to get into phase shifting and vertical shifting, and with that you have one extra step to look at, but for today I just want to look at our high and our low. Okay, and that's at 2 and negative 2, so our amplitude is 2 because we take the absolute value. Now what is our period? Where does it start over? Where does it start over? Okay, so it comes down and back up. It starts over right here. Okay, so if I hit exit out of our annotation mode, it crosses at 4, 0. Okay, our period is 4. Okay, just by looking at the graph. Okay, now what relationship does that have with this guy right here? What relationship does that have? Well, if you remember, our formula was 2 pi over k. Well, k in this case was pi over 2, so it's 2 pi over 2, which essentially is the same as 2 pi times 2 over pi. Okay, and this is over 1, and when we multiply, the pi's cancel out, and 2 times 2 is 4. So our period is 4. Now, once again, we are going to be answering any misconceptions you might have tomorrow, Wednesday. Maybe doing some problems in class. Basically, we'll do our homework. Since you're watching this video, we'll do our homework over this in class, and that way maybe you can see a little bit better from what I was doing. But that essentially ends our video for today. Thank you for your time and patience, and I look forward to any feedback you might have for me.